Edwin Hubble had opened a window to a cosmos inconceivably large and filled with countless galaxies, richly diverse in their sizes and shapes. Elegant spirals, similar to the Milky Way, were discovered throughout the heavens. The graceful arms of these flat galactic pinwheels are formed of gas, dust, and billions of stars. Even more common are elliptical galaxies. Virtually devoid of gas, ellipticals are comprised almost exclusively of stars alone, and are usually spherical or oblong in shape. While smaller, irregular galaxies take on a variety of eccentric forms. About 2% of all known galaxies are classified as irregular. Many of them are satellites of more massive spirals and ellipticals. Once thought to be evenly distributed throughout the universe, we now realize that individual galaxies are instead drawn together, at least in part by gravitational attraction, to form clusters and chains. It has been said that a penny held at arm's length toward the constellation Coma Berenices will block from view a cluster of more than 1,000 galaxies. Important clues to understanding the overall structure of the entire universe may well reside in these galactic clusters. And as astronomers continue to survey and map every corner of the cosmos, a remarkable tool of observation revolutionizes their quest for discovery: the orbiting Hubble Space Telescope. Named in honor of the renowned astronomer, the Hubble telescope captured the attention of the world during its spectacular repair mission in December of 1993.
Tally-ho on Hubble there, Houston. Houston, Endeavour has a firm handshake with Mr. Hubble's telescope. We're taking some great pictures with that.
A team of astronauts aboard the space shuttle Endeavour adjusted and fine-tuned the complex instrument while improving the focusing ability of its optical systems. Since then, the orbiting telescope has more than fulfilled the dreams of astronomers throughout the world.
Outstanding.
Working 300 miles above the haze of our planet's atmosphere, the telescope relies on the predictability and order of the universe to achieve its objectives. When a target area is identified in space, the Hubble's computers lock in on 2 of a possible 15 million predetermined guide stars. This procedure accurately aligns and maintains the position of the instrument as it continually moves around the Earth. The superb clarity and detail of the Hubble photographs have already established the telescope as one of the most significant astronomical tools of all time, reshaping our view of virtually every aspect of the cosmos. Hubble images of the M100 galaxy, 56 million light-years from the Earth, are enabling astronomers to accurately measure distances to stars that could provide vital clues toward computing the true size of the universe. The volatile star Eta Carina. Scientists now have a clear picture of a colossal eruption that ejected fragments of the star far into space at speeds exceeding 2 million miles an hour. With its cameras aimed at the nucleus of M51, the Whirlpool galaxy, this photograph of a mysterious silhouette on the galactic core is believed to be a direct glimpse of a massive black hole. After staring for 10 days at a small patch of sky near the handle of the Big Dipper, the Hubble generated one of the most spectacular pictures in the history of science. At least 1,500 galaxies, many only 1/4 billionth as bright as the dimmest light the human eye can see, were revealed in a single breathtaking panorama. Within a pinpoint of sky, the size of the area blocked by a grain of sand held at arm's length, the scope of galactic diversity and distribution was showcased as never before. At the very limits of the known universe, the Hubble telescope has photographed small, extremely bright galaxies that release incredible amounts of radiation. Quasi-stellar radio sources, or quasars. These distant objects, some 1,000 times brighter than the Milky Way, emit as much energy every second as our sun could radiate in 10 million years. The source of a quasar's power is still unknown, but a popular theory contends there is an enormous black hole in its nucleus. The quasar's gravitational field is strong enough to attract a neighboring galaxy, and in the process, it pulls off huge quantities of stars and gas. As the galaxies merge, the quasar converts its captured fuel supply into radiation strong enough to blaze from the deepest corners of known space. From the vantage point of a mountaintop observatory, the heavens are an open volume waiting to be read. And as a sky filled with individual wonders is surveyed each night, no aspect of the universe proves more striking to behold than its size. Throughout the Old Testament, a recurring phrase is used to describe God's shaping of the cosmos. He stretched out the heavens. Though written more than 3,000 years ago, the words convey a vivid and accurate picture of the universe modern astronomy continues to reveal. The sheer quantity of celestial bodies is almost beyond comprehension. Though estimates continue to rise, it is believed there are at least 100 billion individual galaxies in the universe, many of them comprised of 200 billion stars or more. In an effort to draw these numbers into some kind of meaningful focus, the British astronomer Sir James Jeans speculated that the total number of stars in space could equal or surpass the total number of grains of sand on all the seashores of all the world. And in most cases, each of these stars is separated from any other by trillions of miles. He stretched out the heavens indeed. But how large really is the universe? There is no way to measure precisely, but some perspective can be drawn by using the imagination to survey its boundaries of distance and time. Let us travel now at the speed of light, departing from our home star on a trip across the cosmos toward the edge of the known universe. Our imaginary journey begins at midnight on January 1st, when we prepare to launch into space at the speed of 186,000 miles per second. We quickly pass the orbits of Mercury, Venus, and span the 93 million miles that separate the Earth from the Sun in just 8 minutes 19 seconds. We continue on, passing Mars, then the gas giant planets, Jupiter, Saturn, Uranus, Neptune. Finally, after 5 hours and 31 minutes, we race past Pluto and its companion moon. Our journey has taken us more than 3.5 billion miles to the outer limits of our solar system. And it's still January 1st. Now we alter our flight path and travel in a direction perpendicular to our galaxy. Behind us, the 9 planets and the Sun quickly vanish from sight. The emptiness of space is broken only by the light of stars so distant they do not yet appear to move. A year passes, then 2 years, 3, 4 years. Finally, on April 19th of the 5th year, we reach Alpha Centauri, the nearest star to our solar system. We have traveled more than 25 trillion miles, and our journey has scarcely begun. We are now 10 light years from the Sun, far enough out in space that the stars within our galaxy appear to converge. 100 light years from the Sun, Patterns of gas and nebulous material from the arms of the Milky Way fill our view. 1,000 light years. The galaxy's arms and disk become more defined. Yet it is not until we have traveled at the speed of light for 100,000 years that the entire spiral shape of the Milky Way is recognizable. From here on, each point of light we see is no longer an individual star, but an entire galaxy composed of billions of stars. "5 million years after beginning our journey, the Milky Way is seen as part of a cluster of about 30 galaxies, known as the local group. "50 million light-years out, we encounter the large Virgo cluster,